All right, let's get straight to it. This is a technical breakdown of UML activity diagrams. We're going to focus purely on the syntax and the components. This is your direct reference for understanding the notation.
Here's how we'll structure this. We'll start with the core concepts, then get into control nodes, action and event nodes, cover data and object flow, and we'll finish up with partitions.
Okay, first things first. We have to establish the foundational elements. These are the absolute basics you need to know to read or build any activity diagram.
So the activity itself is the main container. You can think of it as the boundary for the entire process you're modeling. It's represented by that big, round-cornered rectangle that holds everything else inside.
This simple diagram lays out the essentials perfectly. In this send letter activity, you see the initial node. That solid black circle, that's where everything begins. The flow then moves along these arrows, called control flow edges, through the different actions like write letter, and it all concludes at the final node.
Now, this is a crucial distinction. Every single activity has one and only one initial node. It's the unambiguous entry point. However, a process can have multiple valid ways to end, and that's why an activity can have several final nodes, each one marking the end of a specific path through the workflow.
Next up, we'll look at control nodes. These are the components that actually manage the logic and the direction of the workflow. Things like decisions, merges, and forks.
So, this is just a quick visual reference for the control node symbols we're about to dive into. These are the nodes that direct the flow of execution, almost like traffic signals, based on specific rules and conditions.
Decision and merge nodes, they're really two sides of the same coin. The decision node, which is that diamond shape, is where you get a branch in the flow. It's basically asking a question. The merge node, also a diamond, is where you bring those separate alternative paths back together into a single stream.
And this example shows their function perfectly. After getMail, you hit the decision node, which evaluates the guard condition is junk. If that's true, the flow goes to bin mail. If not, it follows the else path to open mail. Then, no matter which path was taken, the merge node brings them back together so the process can continue as one.
Okay, now let's talk about concurrency. A fork node, that thick black bar, takes one incoming flow and splits it into multiple parallel flows that can happen at the same time. Its counterpart, the join node, does the exact opposite. It takes all those parallel flows and waits for every single one to complete before it allows a single outbound flow to continue.
This product process is a great practical example. After design new product, that fork node lets marketing and manufacturing happen at the same time. But the really critical part is the join node. It acts as a gate. The sell product action cannot, under any circumstances, begin until both marketing and manufacturing are finished. It synchronizes the workflow.
So we've covered the flow. Now, what about the actual work being done in the system? And how does that system respond to things like external signals? That's what's next.
Action nodes, highlighted here, are the workhorses of the diagram. They represent the actual executable units of behavior. You could think of them as the verbs in your process model.
You'll run into several key types. A call behavior action lets you nest one activity inside another, which is fantastic for keeping your diagrams modular. A send signal action just fires off an asynchronous message and moves on. And then an accept event action does the opposite. It pauses the flow completely to wait for a specific trigger.
In this example, see that little rake symbol on deliver order? That's the clear indicator of a call behavior action. It means this step actually kicks off a whole separate, more detailed activity diagram. Send invoice is slightly different. It's a call operation action, which means it's calling a specific method on that order object.
This diagram is a perfect demonstration of asynchronous communication. The system sends an authorization request event signal, and then the flow just stops. It waits right there at that accept event node, and it will not move forward until it receives the authorization event back from whatever system it's talking to.
So, we've covered the control flow, but what about the data itself? Processes manipulate data. So now, let's look at how we represent objects and data getting passed between these actions.
We're now going to focus on object nodes, which you can see highlighted in the bottom part of this chart. These are all about showing how data is produced, consumed, and moved through the workflow.
The object node itself is very straightforward. It's just a rectangle that represents a piece of data. It can be an input going into an action or an output coming from an action. The label inside typically just specifies the class of that object, like an order or an invoice.
This slide introduces a very useful notation, pins.
Instead of drawing separate object node rectangles and connecting them with arrows, you can attach these small squares directly to an action. They serve the exact same purpose, showing inputs and outputs, but the result is a much cleaner, more compact, and less cluttered diagram.
So, while pins handle data for a single action, activity parameter nodes define the data scope for the entire activity. They sit right there on the boundary and define the data contract for the whole process. So here, this deliver order activity takes an order object as an input parameter and produces a modified one as its output.
All right, last section. Let's talk about organization. When a process involves multiple different actors or systems, you need a way to clearly show who is responsible for what.
And that mechanism is the activity partition, though you'll almost always hear it called a swim lane. A swim lane is just a column or a row in the diagram that groups all the actions performed by a single entity, whether that's a person, a department, or some other system.
This final diagram really puts it all together. The withdraw cash process is divided into 3 distinct swim lanes, clearly assigning every single action to either the customer, the ATM, or the bank. This structure makes responsibility immediately obvious. By combining these partitions with all the control nodes, actions, and data flows we've discussed, you get a very precise and unambiguous model of a complex workflow.